Next, we look at an example with a continuous random variable. Here, the PDF is given, and on the left-hand side, the PDF is actually plotted. Here, we are going to compute the mean, the second moment, the variance, and the standard deviation. Okay, we'll just apply the definition. Let's start with the mean. The definition is the outcomes, x values, weighted by the PDF values, and integrate over the entire real line. Now, you see, on the entire real line, we have up to 1, the PDF is 0, and beyond 4, the PDF is also 0. Therefore, we do not need to actually include those intervals in the integration. So we'll just use this interval here. And you see we have a two-piece function here. In the interval from 1 to 2, we have this 2 times x minus 1 over 3, and from 2 to 4 we have minus x plus 4 divided by 3. So we are going to plug this in, and the integral from 1 to 2, the PDF is 2 times x minus 1 over 3, and multiply that with x, this x here, okay, and integrate from 1 to 2, and add to that the integral from 2 to 4, x times the PDF, minus x plus 4 divided by 3. If you compute this, this is not that difficult to do. You get 7 over 3. Okay. I will mention this again. I recommend for numerical computations, Wolfram Alpha, the computational engine. It's online. Up to a point, it's free. So just for such computations, you can make use of it. And next, let's look at the second moment. Again, here's the definition. X squared, square of the outcomes, weighted by the PDF value, integrated over the entire real line. Again, we have the integration from 1 to 2, using the first piece of the PDF, and then from 2 to 4, using the second piece, and we have this x squared multipliers in each part of the integration. And you take this integral against the polynomial, not that difficult to take. The result is 35 by 6. To compute the variance, again, I'm going to show you the both ways. First, just use the definition. The outcome x minus the mean squared, weight by the PDF, and integrate over the entire line. Again, from 1 to 2 and 2 to 4, just plug in the PDF values given here. Take the integral, you get 7 over 18. Okay. Alternatively, what you do is second moment minus square of the mean, you get the same value as expected. And finally, of course, you take the square root of this to obtain the standard deviation. Now, next, I'm going to make some remarks on moments in general for both continuous and discrete distributions, and also mixed type. First of all, a finite collection of moments is not a unique descriptor of a distribution. That means you have a bunch of statistics about the distribution. It does not tell the entire story, okay? Or alternatively, let's say you have the first 10 moments of a distribution, okay? Let's say some random variable x, you know the first 10 moments, the first moment, second moment, third moment, up to 10th moment. And let's say you have a second random variable y, and you have its also at first 10 moments. And let's say these two sets are exactly equal. This does not mean x and y have the same distribution. Okay, be careful about that. And a finite collection, it doesn't matter if you have 10, it doesn't matter if you have 10,000, it doesn't matter if you have 10 billion. Okay, as long as it's a finite collection, you can never conclude that if the statistics, if the moments are the same, you cannot conclude that the random variables have the same distribution. Okay, moments by themselves is not a sufficient descriptor of a distribution. Okay, from the distribution you can obtain the moments, but it's not the other way around. From the moments you cannot obtain the distribution. There is one exception to this. When we have the entire set of moments from orders 1 up to infinity, Okay, well, it's an infinite amount of information, but let's assume you have it. Okay, um, the collection of all moments is a unique descriptor of a distribution only on a bounded interval. This means if your random variable has finite support, okay, it's zero below some point, it's zero above some point. In this case, if you have the entire set of moments, then you have all the information you need. But if the support is infinite, okay, the PDF is non-zero over the entire real line, let's say, that even that is not going to be sufficient for you. Okay, so moments and statistics are quite useful values, but they sometimes they do not tell the entire story.